So if your S meter is not very responsive, not very lively, strong signals that you hear very clearly are only registering maybe S3 or 4. My experience has been, I've had 2 units where this was the case. This RF amplifier, which is Q201, was blown. And, well, it was bad anyway. And the clearest indication that it was working, other than the fact that the S meter was sort of, like I said, unresponsive, is if you measure the voltage at gate 1, which according to the service manual is supposed to be 0 volts. In fact, what you'll measure is something more like 0.13 volts or 0.15 volts, and it really should be 0. And what I did in the case of both units that had this issue was I went to eBay and I bought a OEM part from a vendor in China that looked to be reputable, and I waited 2 weeks, got the parts. They look legit. I stuck them in, and in both the units, boom, fixed the problem. Suddenly my S meter was really lively, getting pegged on strong signals, and then I needed to recalibrate the S meter, which we'll talk about here in the future. Okay, talking about the first LO adjustment right now. This is the first LO board. Right here is the 0 megahertz adjustment, and these two caps here are the 29 megahertz adjustment. And these terminals over here are the output. However, I have found that adjusting the first LO with a frequency counter connected to these terminals doesn't work so well because the frequency counter pulls the frequency slightly. So you get everything set up perfect with your frequency counter and then take it off and everything shifts a little bit. What I have found works best is to connect a spectrum analyzer to the antenna terminal of the receiver and measure the LO frequency through the bleed out or bleed through that comes out the antenna terminal. And I'll show you how that's done. Okay, so what we're looking at right now is my little miracle spectrum analyzer. This, by the way, is called a Tiny SA, and if I remember correctly, you can buy these online at R&L Electronics. They're called a Tiny SA, and they cost 80 bucks, including shipping. And this is a very good little decent spectrum analyzer, and it's also a very good and accurate signal generator. So what I've done is I've connected this to the antenna terminal, and now I'm looking at, here's the display, and I'm finding the rotational center of the knob. It's about, we'll call it about there. And what's the frequency? It's showing my frequency as 55.1, and according to the service manual, the correct LO frequency for the 0 megahertz setting is 55.5. So I'm going to call that good enough. And now I'm going to go up to the 29 megahertz spot. Let's get up there. Okay, now this has a much smaller rotational window. This is like maybe 6 degrees. So I'll find the center approximately. And what's my frequency? Oh, got to change the spectrum analyzer. Center 84.5 is what I'm hoping to find. And look, there it is. Boom, right where it's supposed to be. 84.5, good enough for government work. We'll call that done. Now what I would do is I would go back down to 0, double check that, particularly if I had to make any adjustments at the high end, because those adjustments do interact. But I'd go back down, make any final adjustment I needed, and then I would check at 5 megahertz intervals the frequency of the LO to make sure that it was falling within the rotational window of the tuning dial. And if I found the approximate rotational center of the tuning dial where the 26 was displayed, I would expect to find the LO at the proper frequency or within like 100 kilohertz or so. And if it always did that all the way up, then I'd say linearity is good and everything is good to go. Okay, well, we're still talking about the first LO. This is a different view, and here you can see turning the linkage from the dial and the LO capacitor turning. And you'll notice this is a dual gang capacitor. I have found one receiver in which this first LO design was different. It had a different PC board, and it had a single gang capacitor instead of a double gang capacitor. And I had a heck of a time tracking it. I could not get it to track. It was a bad design. Maybe that's why I've only found one out of, I don't know, a dozen units that I've worked on. Only one had that lousy design. And the solution for it is, and I got lucky on this, the problem is that the rotational rate of change of the capacitor was, if I remember correctly, well, it wasn't the same as the rotational rate of change of the linkage that was over here in this display switch. They just would not track. So what I had to do was I had to change the capacitor rate of frequency change. Basically, it's rotational rate of change as a capacitor. And the way I did that was I spread these outside rotators on that single gang, and I used a little pair of needle nose, and I just kind of randomly just bend them outwards a little bit, a 1/16 to an 1/8 of an inch, and checked it, and I just got lucky. It worked perfect, it tracked perfect, and I was grateful. So anyway, maybe that'll help somebody if you are so unfortunate as to have one of those single gang models. If you have problems, other problems with tracking, it's worthwhile to read the information on page 14 of the service manual about how to adjust the linkage, which is basically here in relationship to the switch and the position of the capacitor. That may give you a clue. That may help you get that set up right. If your receiver is not working and your kilohertz display is not working either, then there are a couple things that could cause that problem. One could be that your third LO is not oscillating, and you can measure that right here at test point 303, and it should be operating between, as you tune the kilohertz dial, between 2.455 megahertz and 3.455 megahertz. The other place that you should be able to measure that is on pin 6 of this frequency counter IC, and pin 6 is right in here, because that third LO gets delivered to this counter on pin 6, and the counter actually measures the LO frequency, and it measures it and then subtracts 0.455 megahertz from what it measures, and that's what it displays on the LCD display, or the counter display. The other problem could be if your third LO is working, and if the signal is getting here, then it could be, and this has happened on two different receivers that I had. The 4 megahertz, and here it is right here, 4 megahertz crystal, and its oscillator transistor. I found that both, I think it's what is it, Q506 and Q507 were blowing, and one of them, it's Q507 I think it is the 4 megahertz oscillator transistor, and that 4 megahertz gets delivered to pin 4 of this frequency counter, and if it doesn't have that 4 megahertz clock there, then the counter doesn't work. In the case of those transistors, if I remember correctly, they're both the same transistor, and what I did is I went to eBay and I found an OEM part on eBay, again from China if I recall correctly, bought them, waited a week and a half, got them, plugged them both in, and the oscillator came back to life, everything worked. The other thing, of course, it could be is the frequency counter chip could be bad, and if it's bad, well, you're pretty much SOL, because that part is just unobtainable. While I'm in here talking about this, we'll call it frequency counter module, another failure mode that I had on a unit, which was one of the most unusual failure modes, was the receiver sounded like it was working, and the kilohertz dial worked and tuned, but all the received signals were at like the wrong frequencies, and I had lots of birdies and ghost signals, and it was just, everything was squirrely. And the problem turned out to be this divide by 4 IC here. What happens is that this 4 megahertz that gets delivered for the counter clock also gets delivered to this divide by 4 chip here, and it comes out over here at TP, where is it, right here, I think it is TP501, as a 1 megahertz signal output, and that drives a harmonic generator, which ultimately becomes the second LO. And if this chip fails, there's no 1 megahertz here, no harmonics generated, no second LO, but you'll still be receiving signals. They'll just all be garbled up at the wrong frequency, etc. And yet your kilohertz dial, your counter, will still be counting as if it's tuning the frequency, because it's still, what it really does is it counts that third LO signal. Okay, now I'm going to talk about a problem that I've only seen once, and this is the same receiver that I was just talking about, the slow drift of the third LO, and this is a problem that I recently fixed on this. And the symptom is that the kilohertz tuning dial was very squirrely. All I had to do was just touch it, and the signal would, just warble all around. In fact, I could touch this receiver almost any place on its chassis. If I go like this, it would warble. Trying to tune it, as I said, it was very unstable. If I just tuned it and then left it, everything was fine, but any touch anywhere, any kind of stress, would cause this signal to jump around. And what I finally found it to be was this capacitor here. And unfortunately, this is really a nasty repair to do, because you have to take this whole gear assembly and LO assembly, you have to completely remove it, and you do that from the other side. We're looking at the bottom of the receiver right now. You have to take that out, and then you have to come in through this hole and get this screw out and get this screw out and pull this capacitor. Oh, and you got to unsolder it in like 5 places over here. So you can pull this capacitor out and get to these little teeny screws here at the end. And what I did was use a pair of needle nose pliers that are pretty fine little needle nose pliers, and I could just get a hold of those screws, and I gave them all a 1/4 to 1/2 turn tightening, because they were all, they weren't even snug. And I found that touching this capacitor caused this problem really badly. So I tightened all 4 of these 1/4 to 1/2 turn, going like this and like that, and then I drooled, did not spray, but I drooled, you can't really see it here, a little bit of deoxit down a tab that goes inside, and the tab leads to the bearing position between the stator and the rotator of this capacitor. And so if there was a little oxidation in there, the deoxit got in there, and then I gave it some turns, put the whole thing back together, soldered it back in, and found that that problem was completely gone. The other thing is, though, that I did notice is that on the other side, there's 4 tabs that are part of this assembly that screw it into the chassis. And this, when I stuck it in there, had a little rock in it from the other side. I mean, it would rock back and forth just a little bit, and I felt that any stress in this chassis area could contribute to that problem. So what I did was I took a little star washer and I slid it underneath the 1 foot that seemed to be the source of the rock, because there was about, I don't know, 25 thousandths gap there. The other 3 feet felt nice and solid, but there was a little gap. So I stuck the star washer underneath there. Then there was no rock. Then I screwed it all in place and turned it on, and this problem was completely gone, and I was pretty self-satisfied with that, I must say. Okay, this is a unit that I'm actually working on right now, and one of its many problems, and this is the last one I'm working on right now, is a slow frequency drift. When I tune on a signal, it will just slowly drift off. Now, it takes a long time. It's only drifting maybe a hertz or 2 per second, but it adds up, and pretty soon you got to retune the signal you're listening to. And on single sideband, that's particularly noticeable. And I came to conclude that it's probably this third LO, and the third LO used several polystyrene. That's what these are, polystyrene capacitors, which at the time this receiver was built was the only way to get a fairly high value capacitor that was thermally pretty stable. Nowadays, that's no longer true. In fact, polystyrene capacitors, typically, I don't think they make them anymore. So you can see these little blue dots here. These used to be polystyrene capacitors that are in this third LO, and I have replaced the higher value polystyrenes with NPO/COG ceramic capacitors, which are also just thermally very stable, but I can get the values now in these little teeny things here. And the problem with polystyrene is that they didn't, if they ever got overheated, their values would change, and they'd never recover afterwards. So they have a failure mechanism there. And what I've been doing is I've been replacing those. And when I replace this one right here, which is C339, it tremendously improved my drift problem. I haven't finished the job yet, but I think this is the key to that slow drift that a lot of people complain about on DX-302s. Regarding those capacitors, though, one thing you don't want to do is go changing all these capacitors willy-nilly with NPO or COG capacitors, because a couple of these capacitors are intentionally selected to have negative temperature coefficients. An example is this one right over here. I think it's C341. Yes, it's an N2200, which, if I remember correctly, means it changes 2200 parts per million per degree C or something like that. So it's intentionally selected to drift downward to counteract the temperature coefficient influences of other components in here. So you want to check that before you just start changing capacitors. And I think you find that on, let me check, the service manual, page 33. Yeah, page 33. That lists up in the upper left hand corner of the page the different capacitor types, and I think it lists an S, an X, and I think it's a U version of capacitors, and it defines their temperature coefficients associated with each of those letters. A not uncommon problem on these DXs is a sort of a thumping or ticking as you rotate the megahertz dial. This is more common on the megahertz dial than on the kilohertz dial, and what it is it's the gear on the megahertz dial engaging a spur gear that's inside there, and the spur gear has cracked. And the reason it cracked is because the spur gear is pressed on, and there's like a 6 mil interference fit between the shaft and the inside diameter of the spur gear, and it puts a lot of tension on that nylon spur gear, and they crack, they break. And in fact, this was a problem at the factory too, because I have found several units that have factory repairs, clearly a factory repair where they broke it putting it together, and then they implemented this repair. And this photo I'm showing you right here is an example of that. So what I found worked best for the megahertz ring dial spur gear when it breaks is to get, I think it was a number 63 drill, which has an outside diameter that's essentially identical to the outside diameter of the shaft that the spur gear fits on. And then I slide the gear with its crack over that drill, and I have the drill in my hand, and I just rotate the drill gently while squeezing that spur gear. And what happens is because the drill is bigger, at least initially, than the inside diameter of the spur gear, that gap is spread, and you can see that it's spread. So you squeeze the gear hard and rotate that drill, and it starts reaming out that gear. And eventually what happens is you'll notice that the gap will slowly close, and when the gap closes, stop doing it. Because what you want now is you want to be able to take that spur gear and just have a nice slip fit over the shaft that it's supposed to engage with. You don't want any slop, you just want it to be a nice slip fit. And then what you do is get a good quality plastic, two-part plastic epoxy, like a 10-minute quick set or something, and mix that up good, and then put the epoxy on the inside diameter of the gear, not on the shaft. Because if you put it on the shaft, when you slide the gear on, it's going to squeegee some of that and it's going to push epoxy in front of it, and you're liable to get epoxy where you don't want it. So just put a very light amount in the idea of that gear, and then slide it onto the shaft. Another thing I forgot to mention was, I also take a Dremel tool and I score a couple of slots near the end of the shaft. And I take a X-Acto knife and I maybe cut a couple little divots here along the edges, so that when the epoxy's in there, I can also layer a little epoxy around it, and the epoxy will engage those slots and divots and give me some shear strength. And because there's not a lot of torque on this gear unless you're, one of these unkind people that spin the megahertz dial. But anyway, I found that works, and it works well. The other thing I'll mention is, by the way, we're not looking at that actual shaft and that actual gear. I don't have a photo of that, unfortunately, and I'm too lazy to go take another one. This is another example that's much deeper inside the gear assembly. But it's the same gear, same type shaft, and the same concept. Anyway, I hope that helps somebody. A problem I recently experienced was backlash in the kilohertz dial. A lot of backlash, like maybe 6 degrees of rotational backlash. And what it turned out to be is mistensioning of some gears. And it's kind of hard to explain, and it's going to, again, I'd probably have to write a small book or do a 3-hour video on how to do this in detail. So I will just tell you, this is a really difficult repair, and I hope I never have to do another one of these again. In fact, if I have it, I'm not sure that I would, because it's really a pain. What happens is, see this metal gear right here that's on the outside of the nylon gear? This metal gear has a little tensioning wire or spring associated with it that keeps pressure on these gear teeth and the teeth of the gears that it's engaging over here. So this wants to rotate, this metal gear, and the tension between this wanting to rotate counterclockwise and this one being stationary keeps tension on the gear that's engaged, and that prevents backlash. In this case, the gear tensioning mechanism was misadjusted, and that was the source of the problem. Here you can see this a little bit better. This gear here has these little studs that rotate or slide back and forth in a slot on this metal gear. And on the back side of this is a spring wire that puts tension on this and tries to rotate this. And that's what keeps the tension on the gear and prevents backlash. However, what you have to do to fix this, if you're so unfortunate as to have that, is you have to take the whole gearbox out, take the gear assembly apart, and reposition. You got to remove the little wire, and then you have to reposition or advance the teeth a little bit on this, so this nylon gear stud moves further into the slot that you see over here. You have to re-engage this then into the gear that it's going to engage. You have to hold everything in place while you install that tensioning spring. And I'm going to show you a little bit better picture of that maybe. Let's give that a try. Well, I wish I had a video camera filming all this when I actually did this repair, or maybe I don't wish it, because it was frustrating, and I felt pretty stupid sometimes while everything flew apart and fell apart and I had to do it again. But this shows you that you have to, in this case, you have to get these things all positioned correctly with no tension spring installed. Then there's another plate with other gears that go back on top of this. And now, while you're holding everything together in the correct rotational orientation to one another, you have to install this little spring. And it's really hard. I had to make a little special tool to do that. I'm only recording this because for those of you that have lots of patience, if you have this problem, it is possible to do, but not fun. And I wish you good luck. I hope I never have to do another one of these. So let's talk about audio mods. The audio on this receiver is not that great. Part of it is because the speaker is not that great. Part of it is because the IF amplifier filter bandwidths are not that high. But a very large portion of it is in the audio amplifier itself. The capacitance values are really too small for the intended application. In fact, if you look at the application note from the manufacturer for this chip, the recommended values that are used in the SBE, or excuse me, in the DX-302, are much lower than what the manufacturer actually recommended in their test circuit. However, what I have found is you can get 90% of the benefit from two capacitors, which is C378 and 379. I think in the original DX, as built, they're like 100 microfarads. And I put in 470 microfarads in both slots. You could actually even take this to 1,000 microfarads. But if you put in 470 microfarads in both of these slots, you will get a huge and noticeable improvement in the audio, particularly in the lower frequency range. If you go online, you will find a lot of folks recommending other adjustments to the values. I think it's W4JBM is one of them. If you just Google DX302 mods, you'll come up with his website, and he has a bunch of mods recommended that I'm going to talk a little bit more about in the future. His recommendations for changing, he recommends changing a bunch of other capacitors. They're not wrong, but they're not necessary either. And if you don't really feel like getting into all those capacitor changes, just do these two, kick them up to 470, and that'll make a huge difference. When I made those changes, and when I first started out, I did in fact change all those capacitors. But what I did was I changed these two first, and then I took some data and plotted it. Then I changed all the other ones and plotted them. And what I found was I could definitely see that there was a measurable further additional improvement by making all those other capacitor changes. However, even though I could measure the difference, I have really good hearing, and I couldn't really notice much of a difference. The other thing is this speaker. You can't really see it here. Wait a second, let me readjust. Well, that didn't work out too well. I should have done this. This speaker is not a very good speaker, but you know, it's not that bad either. A lot of people recommend replacing it. That's not a wrong thing to do. However, these speakers are glued in, and sometimes they come out really easy, and sometimes they come out really hard. And unless you have a speaker that you know is actually going to sound better, it's not worth the effort, not really. This is not a high fidelity receiver, and you know, what I found is it's good enough. You can always test it though, of course. Get another speaker, use the external speaker connection, and see, switch back and forth between external and internal, and see if the difference you hear is really worth the trouble. So talking now a little more about the W4JBM modifications that you'll find on that website. There are, probably a half dozen suggested modifications, some related to the audio that I've talked about already, some related to the AGC circuit, IF circuits, gain control, RF front end, and I will say that in my opinion, I wouldn't mess with those. I've been surprised at how many receivers I've looked at that have those mods in them, and in most cases they cause other problems, or they're just ill-advised modifications that don't actually really realize any improvement and often cause some subtle problems. When I find those mods in a unit that I'm working on, I take I take all of them out, except for the audio mods if I find those. But I take all the other mods out because they just cause problems, particularly in the IF gain areas. Also, one of the mods recommends changes to the first RF amplifier. And I think people associate hearing more noise with being more sensitive. And that mod is definitely an ill-advised mod. So that's my recommendation. Another thing that's just kind of worth mentioning that I was surprised to find, maybe you already know this, but this design, the DX-302 design, is basically a realistic or Tandy Corporation ripoff of the Yasu FRG7. I mean, there are circuits in this, if you look at the schematics and compare the two, there are circuits in this DX302 that are exact component copies of the FRG7. And in fact, I would say that this is actually an FRG7 with a digital display. So, it's got a little bit more contemporary technology in it here or there, particularly as it relates to the frequency readout. But a lot of this receiver was just taken directly from the FRG7. And I think both of these receivers are comparable in terms of sensitivity and selectivity. And I actually prefer the DX302 a little bit because, well, the frequency accuracy is just better. There are several factory modifications that I've noticed over the years. Most of them I just leave alone. What I found is most of them don't have too much of an effect, or maybe they're not effects that I notice. And the receivers are working fine. That's the way they ship. I just leave them that way. However, there's two mods here that are worth talking about. One is, where is it? It's done at this transistor right here, which is Q207. What they did was they stuck a 100 ohm resistor in series with a base lead. Now this particular unit is one of the few that doesn't have that mod in it, but they actually lifted up the base lead, stuck a 100 ohm resistor in the base lead hole, and then soldered the two leads together up here above the transistor, and they put a little piece of insulating tubing around it to make it look pretty. And the other thing they do is they omit C, I think it is 230, which is the RF bypass capacitor for the emitter of C230. And I think the reason they did this is because this receiver really has too much IF gain. If you compare this receiver to the Yasu FRG7, this portion of the receiver is basically identical. Tandy Realistic ripped off the Yasu design, but for some reason, and it only has a single gain block, the Yasu does. This receiver has two gain blocks. It doesn't need them. So I think when they added this gain block, they found out they had way too much IF gain and it was causing them problems. So they omitted that capacitor to reduce the gain. It was really a kludgy production mod, I would say, but it worked. And then they probably added that 100 ohm resistor to prevent self-oscillation or motor boating, and also to reduce gain. Anyway, the first time I found that, I thought it was a customer mod, and I reinstalled C230, and I found that, oh, it was a problem because the receiver just had so much IF gain that I couldn't align it properly. Then I got a second unit and realized it had the same mod in it, and that's when I began to realize, oh, this is a factory mod. And I've looked at 10 units here in the last 2 years, and every one of them had that capacitor missing. And most of them had that 100 ohm resistor put in there. So I tend to leave these things as they left the factory, and I just thought it was interesting. A really useful document to have when you're working on the DX is the service manual, which is pretty worthwhile. It's most readily available at manualslib.com, just like it sounds. And that's about a 54-page document. And it's most valuable because it includes the schematic. It has PC board views, top and bottom. It has the component list, part numbers, and it has a lot of voltage charts or voltage tables telling you what voltages ought to be there. It also has some pretty helpful alignment information. However, the first portion of that, which starts on about page 9, which is this long flow diagram of how to do operational checks and stuff, I think that's a complete waste of time. And I mean, there is buried in that some tidbits of useful information, but it's not something you want to actually try and follow. Still, it's worthwhile to download that. Very useful. Unless you have the proper equipment and the training, I suggest you resist the urge to mess with these IF adjustments in here. An IF filter is more about bandwidth and skirt steepness and the shape or frequency response of the filter than it is minimum loss. And I've had a couple units where people tried to eke more gain out of their receiver for some reason, and they got in here and they adjusted these things using the S meter, and that will absolutely hose up your IF filter and your selectivity and your adjacent signal rejection. So unless you've got the ability to do a swept measurement and you've got the training or experience to properly align a multi-pole filter, I suggest you stay away from these. One thing I will say is that I have looked at about 10 units, and almost all the IFs were acceptably aligned. Maybe not optimally aligned, but good enough for the receiver to work properly. And the one or two that weren't, it's because the customer had gotten in there, or somebody had gotten in there at some time in this receiver's past and fiddled with those and got it all hosed up. If you need to, for any reason, check your second LO output, you get your spectrum analyzer connected to TP206, which I'll show you here in a moment. And this is the spectrum analyzer, 5 megahertz total span, centered up at 52.5 megahertz. And here I've got my megahertz dial set to 29, and you'll see here's your second LO output centered at 52.5 megahertz, and it's about minus 55 dBm. And as I go tune the unit down, the megahertz dial down, you'll see those pickets coming up. And here I am at 22 megahertz, and you can see again, here's my second LO power. It's at about minus 52. And of course, as you go lower in frequency, the second LO pickup power is going to tend to increase, and probably will, if I get all the way down here, right there, here's a good spot. So at 10 megahertz, my second LO power is minus 50 dBm. And if you check your second LO and you find that the power is anywhere in that minus 45 to minus 60 dBm level, and it's centered up as it should be right there at 52.5 megahertz, then you know that your second LO is there and is working pretty good. And again, you do that at test point 206, and I'll just very lamely pick this up and show that to you. There it is, test point 206. The best explanation for how that second LO works is found in the service manual. It's a little bit of a mind bender, so I'm not going to try and describe it to you here. I had to read it about 4 times before I understood it. But that's where to look if you want to understand how that second LO is generated.